this video we'll talk about example for the hydrostatic and deviatoric stress, and hopefully to shine some light or shed some light for the invariants of the deviatoric stress. Alright, so yeah, in order to start, I have a stress tensor over here. It somewhat describes the cube, if you still remember, or a body I would say, because it's somewhat with so many stress state. So it somewhat describes the state of the body itself. Alright, and this stress tensor is all this value, and if you want to find a hydrostatic stress, you're taking the trace or the diagonal part and sum them up together and divide it by 3, you'll get your hydrostatic stress. Alright, and because it spans the 3 dimension, your hydrostatic stress is in terms of this matrix over here, sigma h, sigma h, and sigma h. And done. This is your hydrostatic stress. This is just straightforward. Once you get it, if you have your stress tensor, you can straight away find it straight away. Alright, no doubt about it. Now, next thing, using the same stress tensor, alright, and knowing our hydrostatic stress, now we want to find our deviatoric stress. This is our stress tensor, the same thing that we have just started just now, alright, or this one. It's the same thing, alright, it's just the same. It's the stress state of the body. In other words, this is your hydrostatic stress, which we have found earlier. If you take the stress tensor minus away the hydrostatic, what will I have is a deviatoric. And that's it. This is your deviatoric stress. Okay? Now, just like the last video, if you don't understand the last video, then I think you might not understand this part right now. Okay? So, if you want to find, this is your deviatoric stress, right? And if you were to look back to your this slide, this is what is being represented over here. Alright, this is the deviatoric stress. Now, in order to find the invariance, you have to change this dude over here, okay, to a principal stress. So how do you change this thing over here to a principal stress? Alright, it all goes back to how to change a certain how to find the principal stress. It's simply taking whatever stress tensor and minus away I think you get what I mean. It's just to find the tensor itself. Alright, yeah, anyway, let's continue first, so that you'll know what I mean. So in order to find the principal stress of this deviatoric stress, we can assume that this one is our new stress tensor. Alright, so it's minus sigma, sigma, sigma. Okay, and then this whole thing, alright, determinant equals to 0. Alright, and then you can straight away find the values for your so-called the deviatoric principal stress. All this value over here, or in other words, from this slide, alright, this over here is our principle of our deviatoric stress. Okay. Now, in order to find the invariance, you may be tempting to use this formula, but this formula doesn't apply to this one, because this is just the deviatoric stress, which is this one. Alright, but the equation that is given is for this one. Alright, you get what I mean? Because okay, this this thing is the deviatoric stress. Alright, in order to find the principle of the deviatoric stress, this is where I minus this principle of the deviatoric stress, and then I solve for its determinant. I will get this value. So at the end of the day, I'm actually finding the values for all this. Alright, so it should be like maybe 5, 2, 3, for example. For example, I have these values over here. Alright, then this is our principle for deviatoric stress. Okay, which is this one. Okay, so when you have this one, then you can find your sigma 1, because it's just simply minus hydrostatic stress. Alright, because the value that I showed you earlier, for example, in that example, alright, is 5, right? For example, 5. And previously we know that our hydrostatic stress is 13.3, correct? So our outcome is simply this total value is 5 is equals to sigma 1 minus sigma h, where sigma h is in fact minus 13.3. Should be, is it minus 13.3? No, it's 13.3. Okay, so sigma 1 minus 13.3 is equals to 5, and therefore our sigma 1 is 18.3, for example. So you have this value, then, and also you have this value for this one and this case, then you can sub in into this, and this is where this equation apply. Alright, but for our case in this current example, if you want to find invariance, you no need to go all the way through this one. You no need to find all this. Right? You don't need to find all this. This is when, if you are given the principle of the deviatoric stress, then you can apply this formula that is where am I? It's given to you. Right? If you are given the principle of the deviatoric stress. But however, in our case, we're only given the raw deviatoric stress without the principle. So we have to find, which is not good, right? Which is very inappropriate. And therefore, in order to do that, in order to find our invariance, if you still remember, we are going to find the invariance, then we are just simply applying the formula that is to find the principal stress, which is this one. Okay, so you're going to apply I1, I2, and I3. Alright, so in this case, sigma 1, 1, sigma 2, 2, and sigma 3, 3, and the rest is simply this one. This is sigma 1, 1, this is sigma 1, 2, sigma 1, 3, etc. So you just sub in all this value and you can find your invariance using this formula. So this is a general formula to find the principal stress. Alright? This is a general formula to find the invariance, with a given stress tensor. In this case, this is a deviatoric tensor for your info. Alright? So I hope that this doesn't confuse you things, but rather that makes things more clearer. And there you go. This is the example to actually get a feel of the invariance equations and how they're actually being utilized. In the next video, we'll talk about a real full system principal stress type of example. So see you there.